Let's take a look at section 9.1 where we're talking about transformations of functions. We want to begin by looking at shifts and reflections. What I want to do is go to our examples and talk about each of these as we look at the examples. So in this example, f of x is our function, the absolute value of x. Now, one of the things about that function is that it is really the graph of two lines. And one line is the line y equal x. The other line is the graph of y equal negative x. And the two meet at the origin. So this is a graph that you need to come to know and be familiar with. Let's take a moment and look at what it looks like. So here's what the graph of f of x equals the square root of x looks like. So it's a V-shaped graph. And how wide it is or how narrow it is, where the point of the V is, so by point I mean this where the where the graph changes direction. Here the graph is going downhill. At this point it suddenly turns around and starts going uphill. And so all of the when I look at g of x, all of these numbers, the 1/2, the 2, the -1, all play a role. So the first thing I want to look at is the vertical shift that's happening with this function. So let's take a look at that. All right, so notice g of x is actually 1/2 times f of x plus 2 minus 1. So that's another way we could think about g if we want to talk about it in terms of f. Now, according to what we see here, if I have a positive number c and my function is f of x plus c or f of x minus c, then I have a vertical shift going on. So if I'm adding that positive number c, the vertical shift is upward. If I'm subtracting that positive number c, the vertical shift is downward. And so we see that g of x, and so I'm going to highlight by making it red. This is the part of the graph that is the vertical shift, this red part. So g of x shifts f of x 1 unit down, since I'm subtracting the positive number 1 from f of x. So if I take every point on this graph and move the point 1 unit down, so let's say I move this, a lot of time this would be called a vertex also. Let's say I move that point 1 unit down. I take this point, it will get moved 1 unit down. This point gets moved 1 unit down, and so do all of the points on the graph. So notice the y's have a 1 subtracted from their previous value. Let's look at what happens if we move that entire graph, every point of the graph, 1 unit down. And we're going to graph this in red and take a look at it. So this is the red graph, is what the function becomes when we shift every point 1 unit down. So this is what we would see. And the graph of f of x is now a dashed graph, because once we shift 1 unit down, so in other words, all we've done so far is g of x equals f of x minus 1. So that's what you see on the graph right now. Now let's talk about the other transformations that are happening in the graph. We see that there's the input to the function is no longer x, but now it's x plus 2. This is a horizontal shift. Let's take a look at that. So g of x has within it this 1/2, which we'll talk about later, and then this plus 2. We've already talked about the minus 1. So the changing the input from x to x plus 2, according to this information, is a horizontal shift. If c is a positive number, y equal f of x plus c is obtained by shifting the graph of y equal f of x horizontally to the left c units. So g of x shifts f of x two units left. And up here, let's call this h of x, just to give it a different name. So the graph that we see before us shifts f of x 1 unit down. So that's the graph of h, where all we do to f is shift it 1 unit down. Now let's look at what it looks like when we shift 1 unit down and 2 units left.
I'm in charge. I know
So here we're going to, here we have a picture of what happens once you incorporate the horizontal shift to the left. So notice every point on the red dash graph is now moved 2 units left and is relocated on the red solid graph. So this is the effect of the horizontal shift. F of x plus 2 is the portion of the graph that shifts f of x 2 units to the left. So the last thing we need to look at is the vertical stretch and compression. And so here we see that if a is a positive real number, y equal a times f of x is obtained by multiplying each y coordinate of y equal f of x by a. So if a is bigger than 1, the graph of y equal a times f of x is a vertical stretch of the graph of y equal f of x. If a is between 0 and 1, the graph of y equal a times f of x is a vertical compression. And so we see that our function g of x is actually 1/2 So now we want to talk about that 1/2 times f of x plus 2 minus 1. So the 1/2 is actually a vertical compression, since 1/2 is between 0 and 1. So g of x compresses y equal f of x vertically. And you can see the picture of that here. And notice that's by a factor of 1/2. So every y coordinate of f of x is not only shifted 1 unit down, but also multiplied by 1/2. So that turns into a vertical compression. So notice how this graph is actually wider than, so we started with the blue graph. That's the graph of y equal absolute value of x. That's the blue graph. And notice we end up with the red graph where y, and this is actually y equal f of x, which equals the square absolute value of x. And we end up on the solid red graph with y equal g of x, which equals 1/2 times the absolute value of x plus 2 minus 1. So notice what happened to every point. Every point was shifted 1 unit down, then 2 units left, and then vertically compressed by a factor of 1/2. So notice how a vertical compression makes the graph wider than it was. It's as if you're taking it and you're squishing it in the downward direction. And so if you take something and squish it down, you don't change its what you actually, the physical mass of what you have, you're going to get a vertical compression. So think about taking a can and smashing it down. Okay, you're actually compressing that vertically. And so we can see that the effect that has on the graph is that the graph is wider than it was originally. That's the effect the vertical compression has. All right, so those are the things that G does to F. G shifts F 2 units left, 1 unit down, and vertically compresses F by a factor of 1/2.